Hello, this is my English speaking practice, and as usual, I'm working on the problems on lead code. Yep. Remove duplicates from sorted list 2. Given the head of a sorted linked list, delete all nodes that have duplicate numbers, leaving only distinct numbers from the original list. Return the linked list sorted as well. Okay. So given 1, 2, 3, 3, 4, 4, 5, we will have to remove 3 and 4, so the output is 1, 2, 5. Okay. Makes sense. Oh, it's October. Okay. Delete duplicates. So since we handle linked list, we just switch switch the pointer. So for example, when we find the duplicates, we have to keep track on the previous node before the duplicates. So in this case, the new 2 is the previous node, and we find the duplicates here, and we also find this is not duplicates at this time. So we should update the previous node's next field to here. And after that, we start again to find the duplicates, and we find 4 is the duplicates, and we still keep track of previous node here, so we can update it as well. We can update the next field as well. That's what I'm thinking. And in this case, we can do it likewise. But we want a dummy node as a head of the list. We prepare the dummy node here and start to find duplicates at the first. And is there any edge cases? Duplicates start from first, and how about duplicates exists at last? For example, 1, 2, 3, 3, 4, 4. We find 3 is the duplicates, and we update the next field. And after that, we also find 4 is the duplicates. and in this case this is the last node, so we update next field to none. Yeah, but this is not edge cases because we can do it as usual, as normal. Yeah, so we can handle it in the main loop, I think. So we create okay, the node might be empty, so yeah, if head is none, we return none. That's it. And we create the dummy node as a head of linked list. So like this, we initialize the list node and dummy. Okay, we can initialize here and like this, and we want to use 2 pointers because we have to point to positions, the previous one and pointer for scanning. So the name is yeah, fixed and scanning, and we can initialize them with dummy node, and while scanning next is not none, while scanning next exists, we check it, so we can point we can point okay, so let me think. Yeah, when we find the different node, so that means yeah, we find scanning and the next node. If it is the same, we move the pointer forward. So scanning's gonna be scanning next. Yeah, as long as it's the same. And if it's not the same, scanning points here and scanning next is this. So we break the loop, and we should update the fixed node. Fixed next gonna be scanning next. Right. Oh, but how to fix the fixed node? in this case 1 and 2, we look at 1 and 2, so it's not the same, so we can fix the next is, oh wait, fixed is oh, this is not correct. Scanning. Yeah, so let's think about this case. It start at dummy and scanning is head. Scanning start at head, and we look at these two nodes, and it's not the same, so wait. It's not the same, but we have to yeah, so it's not always we can update, we can advance the pointer, fix the pointer just because we find the not a duplicate nodes. So what is the condition to move the fixed pointer forward? We find 1 and next we find 2. Yeah, at the time we find 1 is the no duplicate, so we can fix this, right? And yeah, okay, so we have we need another condition, because this is for in this process we cannot find that we cannot find there is duplicates or not, because yeah, okay, maybe we can know it. We know it. Yes. Yeah. if it reach here once, there is a duplicate. There are duplicates. So if there are duplicates, we just update the fixed next field. But otherwise, there is no duplicates. So, for example, the loop start at 1, and 1 and 2 is not the same. So we'll reach here. So the we can fix the left node. That means fixed is scanning, right? Fixed is scanning, and how about yeah, fixed is scanning, and we should update the scanning forward. I think so. Okay, let me see. If there is no duplicates, the fixed node gonna be scanning node, and then we update the scanning node forward. Yeah, and we go to next loop, and scanning is here, and we look at them, and they are different value, so that we can we update fix a node and move forward, and we look at them, and they are the same. So in this case, duplicates is true, and we move the scanning pointer forward, and look at them. They are different. So but we go inside this loop, so that duplicates is true. Scanning's here, and scanning's pointer here. Yeah, and they are different, but this flag is true. Yeah, because the scanning pointer is located here at first. Yeah, okay. So in this case, the fixed node's next field is gonna be 4. Okay. And scanning is updated to this node. Okay. And it's same, move forward, and it's different, but its duplicate flag is true, so we can update the next field to here. Yeah, and we return the next field of dummy node. because we might be update the original head node like this. Okay, so let me run it. Nice. Oh, I see. Scanning is not now, but I'm going to. What? Scanning might be none. And we can oh great. And maybe we don't need to do like this. But it's okay. So the time to learn English. So okay, we handle an edge case. If it's none, but I found this is not necessary. Because we handle this case in loop below. Yeah, we create a pivot node. Since because we want to handle the head node as normal, as a normal case, as a normal. Well, it's okay as normal. Yeah. Fixed pointer. This is don't have the duplicates. Scanning pointer. This points a node that we inspect, we iterate, inspect, we check, yeah. We loop it while and we check if there is a duplicates, and we want to move the scanning pointer forward as long as they are the same. Okay. If they are the same at least once, we cannot fix the node. We just update the next field. We just update the next field of the current fixed node. Yeah. Otherwise, the scanning node doesn't have any duplicates, so we can fix the node. Fix the node. We can update the fixed node. We can fix the node. Which means we move the fixed pointer to scanning. To the scanning position. And finally we advance the scanning pointer, yeah, and we return the next field of the dummy node because the head might be dropped. Okay. We handle the edge case. Which doesn't have duplicates. Typo. We want to move the scanning pointer forward as long as they are same. Clunky. We move the scanning pointer forward while the values are the same. Values are the same. They are the same. Values are the same. Yeah, right. Handle the edge case. If the list is empty, just return none. Actually, not strictly necessarily, since the loop below covers it. Covers it. Create a dummy node so we can treat the head like any other nodes. Fixed pointer points to the last confirmed unique node. Last confirmed unique node. The last confirmed unique node. Scanning pointer moves forward to check for duplicates. Iterate while scanning has a next node. Check if there are duplicates. Move scanning forward while the next node has the same value. If duplicates were found, skip them by updating field. Otherwise, scanning is unique, so move fixed forward. Finally, advanced scanning randomly next, since the original head might have been removed. Yeah, but there are a few corrections, so yeah, my English is improving. I feel like my English is improving. Okay, go next. Partition list. given the head of a linked list and the value x, partition it such that all nodes less than x come before nodes greater than or equal to x. You should preserve the original relative order of the nodes in each of the two partitions. All nodes less than x come before nodes greater than or equal to x. I cannot understand the English. Partition it such that all nodes less than x. All nodes less than x come before nodes greater than or equal to x. So that means greater than or equal x. And before all nodes less than x come before. Oh, let me think it in English. All nodes x より小さいすべてのノードがbefore に来なければならない。x 以上のノード x 以上のノードと x 以上のノードかそうでないかに分けて、x 未満のノードが前側に来なければならない。で、you should preserve the original relative order of the node in each of the two partitions. Okay, so in this case, the x is 3, so we can what? Or in my understanding, the x is 3, so we can partition 3, 4, 5 or less than 3. So in this case, 1, 2, 2. Yeah, 1, 2, 2 have to. Okay. That makes sense. So we should preserve the original relative order of the nodes. So we can partition it 1, 2, 2 and 4, 3, 5. Goes 4, 5 is greater than 3, so we have two groups, 1, 2, 2 and 3, 4, 5. And we have to preserve the original relative order, so 1, 2, 2 and 4, 3, 5. So the output is like this. Okay. How to do that? How do I? Okay, so in this case, since they are the linked list, so we have only one option to scan it from the start. So we scan it and we scan this, and at this time 4 is greater than 3, so this node gonna be the first element of the second part, Yeah, the second part means this group. Yeah, so this node gonna be the head of the second group, and we move forward, move scanning forward. Yeah, this is good. Now we look at it, and this is less than 3, so this should be forward than head of the second part. Yeah, rather than head of second part, we should keep track of the last element of the first part. So in this case, at this time, this node is the last element of the first part. Alright, so when we look at this node, this should be in the first part, so we update the next field of the last element of the first part to this point. And also we have to update the next field of this because this is the new last element of the first part, so it should look it should connect to the first element of the second part, right? And also I'm not sure. I also update the next field of the last element of the second part. Okay, so yeah, we need 3 pointers. I think. Yes. Let me handle the edge case. If the head is none, we return none. We might remove this later. And yeah, we look at second for first let me take a break. Just a moment. Hi, I'm back. And okay, so let's work on last first and head second. Yep. So and scanning. Last first should be none, and scanning start with head. Okay. Yeah. So while scanning next exists, we loop, and if the scanning node is the value of scanning node is less than the target value, should update the gonna be scanning, and last first is updated to scanning. Otherwise, head of second. Maybe we need two last nodes for first and second group. And the scanning update the scanning node. We don't need this condition, just look at the scanning. Yeah, that's simple. And finally we should update okay, I understand. First node, sorry, Yeah. Hmm? Wait. So 1, 2, 2, and 4, 3, 5. And the pivot is here. Pivot is also here. Pivot first, pivot second. So finally, we have to connect these nodes. Hmm. And also we have to update the next field of previous node. I'm confused. 1, 4, 3. No, don't need to update because the next field would be updated later. Yeah. Yes. But we have the two nodes that wouldn't be update. These two nodes are the last element of each groups, so they are not updated. So we have to update it, but it's okay because we have to connect this. So this one is updated, and also I know the last element of the second group, so I can do it easily. Yeah. But we don't know the first element of the second group. I know it. That means gonna be And finally, yeah. Yes. And return the pivot first group next. How about this? Great. Submit it. Great. Perfect. Yeah. And okay, it's time to learn English. How about this? We can remove this. Yeah, because the head is none, we don't process this while loop, so the pivot, the next field of pivot of first group is none, so just return none. So that's we can remove this, but this is for English learning, so I will explain it in English. Yeah. Covers this case. So here we pair two groups codes. And to make it easy to handle, we use pivot nodes for each group. Yep. and we keep track of the last node for each group. And we yeah, we categorize, if the value is less than the target value, yeah, we sort, we group, categorize, classify, categorize, categorize, classify, we sort, we put it to the first group. Yeah, we have the last element of the first group. So we just update the next field of it, and then possibility. There is possibility the last Yeah. Necessary. Handle edge cases with redundance. We prepare two groups because we need to partition the list. To make this easier, we use dummy pivot nodes for each group. We keep track of the last node for each group, and then we iterate through the list starting from head. If the value is less than the target value, we put it to the first group. If the value is less than x, put it in the first group. We have the last element of the first group. We already have the last node of the first group, so we just update its next point. We do the same for the second group if the value is greater than or equal to. We do the same. Connect the first group to the second group. Update the last node since there is possibility it still has a next pointer. Next pointer, yeah. Return the next pointer of the first pivot node, which is the head of the partitioned list. Wrong articles, typos, slightly unnatural phrases. Put it in, iterate it. Okay. Oh. Nice. Okay, can I go to next? Gray code. An n-bit gray code sequence is a sequence of n power of n integers where each integer is in the inclusive range. The first integer is 0. integer appears no more than once in the sequence, the binary representation of each pair of adjacent integers differs by exactly 1 bit, and the binary representation of the first and last integers differs by exactly. Okay. I quit. I quit the stream. I'm going to the bed. Yeah, because it looks like, yeah, it take it looks like it will take really long. It looks like it will take too long. Yes.